So we'll continue solving these equations. We want to think about our reverse order of operations when we need to and remove anything around our base to the exponent equals number before we're ready to go to log form. So on exercise 3a, this is already base to the exponent equals a number. So I'm going to do log base of the number. So this is base, exponent, and number, and this equals the exponent. So in your calculator, you are going to type that logarithm, directions set to the nearest hundredth. So this is going to be x equals 0.83. In the next problem, we have something else around the base to the exponent equals the number. We have this extra 4, so we have to subtract that over. Now, even though there's division in my exponent, we do have a base, an exponent, and a number, and nothing else, so we are ready to go to log form. So the base is 5, the number of the equation is equal to this 43.6, and this is x over 12. If I type this in my calculator, I get approximately 2.35. I will keep that number in my calculator. And then to finish solving this, I will take that whole decimal, not just the 2.35, and multiply by 12. And to the nearest hundredth, that gives me 28.15. So on the next page, I would suggest trying these 4 problems and then coming back and checking them. Maybe you want to watch the first one, but if you're ready, you can go ahead and try them. So looking at the first equation, this is a really probable situation. A lot of our equations have a number times the base. So we always need to get rid of that number because that's not part of the base. So 20,000 divided by 1,000 is going to be 20. Now we have a base, an exponent, and a number, so we're ready for log form. So the base is 1.08, the number is 20, and my exponent is 12t. I just want to give another option. You can wait until you divide by 12 and then type this all in your calculator. That's also an option. Or you could type the log base 1.08 of 20 in your calculator first and then divide by 12. So if I choose to type it in all as once, or if I choose to do it step by step, either way I'm going to get 3.24. In the next problem, we also have a number in the front that we have to divide by first, right? Because we take care of multiplication and division before we do exponents. The log step is an exponent step because logs equal exponents, so we want to do the multiplication and division first. So converting over to log form, and then typing that in my calculator, I get 58.37 equals x. On the next one, I have 2 steps of things to get rid of. And then I also need to divide by 4, and I get 2 to the x equals 5. Now I'm ready for log form. And if I take that in my calculator, I'm going to get 2.22. So I'm going a little faster now, but if you need slower examples, you can go back to some of the previous ones. F is a little different. It looks like there's a lot going on, but all of this is in the exponent, so we are in base to the exponent equals number. So we're ready to put it in log form. My exponent is 3x plus 2. This time I am going to take this in, keeping the whole decimal in my calculator. I get 2.87. And then we are just doing subtraction first, and then division to keep solving this equation. If your answer is slightly different, you probably at some point rounded too early. You should get 0.29. So now we're going to connect this to the word problems that we did in the last lesson. So this says the money in your bank account, which is currently $527, increases by 4% each month. Write an exponential function that models this situation. So we know our exponential functions are in the form p times 1 plus r to the t. I'll write over here a equals, just so we have an actual equation. So it doesn't tell me what variables to use, so I'm going to stick with these. Maybe I'll write a of t. And this is starting with 527 we're increasing by 4%, so 1 plus 0.04 is 1.04 to the t. We want to know when the amount of money in the account will double. So we want to look at our initial amount, which is 527, and to double that, 2 times 527 is going to give me 1,054. So 1,054, we're plugging in for our amount. That's the amount we want to get to. So from here, the next thing we're going to do is divide by 527. And it shouldn't seem that weird. This is going to come out to 2 because we doubled our initial amount. So now we're ready. We have Venn form. We're going to put it in log base number equals exponent. And now I'm going to type that in my calculator. I do not have this one calculated already, so it's going to take me a second. So, and I get to the nearest tenth, 17.7 years. The next problem is similar. We want to use that same formula. It says the population of elephants in Africa is currently 497,000 and is decreasing 6% per year. If the trend continues, algebraically determine the number of years for the population of elephants to reach 300,000. So there are other ways to solve this, maybe graphically or get some check, but whenever we say algebraically, we know we have to use some sort of process like we've been doing. So my starting value is 497,000. I'm decreasing 6%, so that's 1 minus 0.06, which is going to give me a base of 0.94 to the t. And I want to know when it decreases down to 300,000. So now we're ready to start solving. Right, the first thing we're going to do is divide. And that's going to give me, to a couple decimal places, 0.6036. And you are always going to choose whatever you want to round to in these intermediate steps, just at the end. Make sure you're keeping the whole decimal, make sure you're rounding the correct, whatever is asked for at the end. So we're ready for log form. Don't like the way that base looks. 0.94 of 0.6036 equals t. And if I take that in with the whole decimal to the nearest tenth, that's going to give me 8.2 years.